Welcome back, everyone, and we are in our discussion of stoichiometry. Last time we learned about the limiting reagent, and today we want to learn about the excess reagent, the excess reactant, and if we have time, we want to get into percentage yield. Let us start here with this. Consider we have 28 hamburger patties, 63 slices of bun, and 25 slices of cheese. Again, so how many slices of cheese and slices of bun are left over? Okay. Well, we kind of started this problem before, right? Let's go back up here. And we had 28 hamburger patties, and we wanted to know what's my limiting reagent. And we decided that my limiting reagent, or what limited the number of Big Macs, was my hamburger patties, right? Because if I had 28 hamburger patties, I could only make 14 Big Macs. Whereas if I had 25 cheeses, I could make 25 Big Macs. And if I had 63 slices of bread, I could make 21 Big Macs. And we said, okay, the least amount of product indicates to us which of our reactants limits our production. And so we said we had 28 hamburger patties, and that was my limiting amount, right? Okay, so how do we handle this? Well, what we know is that 28 hamburger patties are going to run out. And when I've run out of those 28 hamburger patties, and we said what, one Big Mac per two hamburger patties, that I'd end up with 14 Big Macs, right? Now the question though is, how much cheese and buns do I have left over? Well, to understand that, I have to figure out how much cheese was used. Well, if I have 28 hamburger patties, and let's remind ourselves, there's two hamburger patties plus one slice of cheese plus 3 slices of bread equals one Big Mac, right? Good. So if I have 28 hamburger patties, and we know these are all going to be used up. Why? Because they are the limiting reagent, we said, right? If I have 28 hamburger patties, and I have what? One slice of cheese per two hamburger patties, right? Good. Some hamburger patties cancel, and I get 14 slices of cheese. And what is that? Well, that's how many slices of cheese are used to make my 14 Big Macs to use up my 28 hamburger patties. So I have 14 cheeses used. Well, how many cheeses did I start with? Well, I started with 25. So I started with 25 cheeses, and I subtract 14 cheeses. And what am I left with? I have 11 cheeses which remain. That means I still have 11 pieces of cheese after all my 28 hamburgers have been used up. What about buns, right? I have 28 hamburger patties. And how many buns? 3 slices of bread per what? 2 hamburger patties. So what is it? That's 14. So I get 14, right? And then I have to multiply that by 3. 3 times 12, 1, 30, 42. So that's 42 slices of bread, which are what? Used. I have 42 slices of bread used. Used how? Using up these 28 Big Macs to do what? Excuse me, 28 hamburger patties to do what? Make 14 Big Macs. Now, how many slices of bread did I start with? I started with 63 slices of bread. So I have 63 slices of bread to start with, minus 42 slices of bread which were used. And what does that leave me with? Looks to me like I have 21 slices of bread left over, which remain. Hey, there we go. So we figure out how much excess, how much of my cheese and bun are left over. Great. Well, that's exactly what we do in stoichiometry. Yipes. In stoichiometry. When they're asking us, let's see, what is this? Oops, I'm in the wrong spot again. Sorry, got to go down here. Here we go. There we go. When they ask us about how much excess reactant remains, that's what we do, exactly what we did with our Big Macs. I've got nitrogen and it reacts with 3 hydrogens to form 2 ammonias. We've seen that before. If you were to react 25 grams of nitrogen with 20 grams of hydrogen, how many grams of the excess reagent remains? Okay, let's talk about the process here. Let's go up and do some notes, right? We've got stoichiometry, and we're right now talking about the calculations that can be done in stoichiometry. And one is very basic, where we go like mole of reactant to mole of product, right? And how do we do that? We use our mole ratio, right? Or I could go grams of reactant to mole of reactant, use mole ratio to get mole of product to give grams of product, right? And all I have to do that is this is divide by my molar mass of my reactant, and this would be multiplied by the molar mass of my product, right? And then we said we can do some more specialized kinds of reactions called limiting reagent, right? Or limiting reactant questions, right? And we said, well, the process is number one, calculate a product from one reactant. So we'll take reactant one and calculate product one using mole ratio, right? And then we're going to take reactant two and calculate product one again using its mole ratio. And then we're going to compare the amounts of product 1 to product 2. And the limiting reagent produces the lesser amount of product. Excuse me, product 1. We compare my two products from, this is from reactant 2, this is from reactant 1, right? So the limiting reagent is the one that produces the lesser amount of product. So if this product is less, that means reactant 2 is the limiting reagent. Good. Now, we have a question about excess reactant. All right, so that's what we're doing now. Now, what's the excess reactant? It is the reactant which is not completely consumed. Completely consumed, right? Which means it is not the limiting reagent. Now, what's the process for determining amount? Okay, so how do we determine the amount of excess reagent left over? That's what we mean. How much still remains? Well, step one, we want to determine our limiting reagent. So we're going to do all this stuff up there. Step two, we want to calculate amount of excess reagent used. How am I going to do that? I'm going to take my limiting reagent, use my mole ratio, and between what? Between my excess reagent and my limiting reagent. And that will tell me how much of my excess reagent was used. All right, so I'm going to use my limiting reagent and stoichiometry to calculate my excess reagent, and that's how much is used reacting with my limiting reagent. Then I'm going to take my original amount of excess reagent minus the excess reagent used, the amount of excess reagent used, and that will be the excess reagent which is left over. Okay? It's really not that bad, folks. Although it can frighten some people, it's really not. Okay, so let us look up here. Here's our reaction. Can we go back here and get some information from it? Yeah, that's not it. Is that it? Oh my God, it's horrible, horrible. Okay, well, maybe we should start all over. That's kind of confusing. I've got 20, I have, what, 25 grams of nitrogen. Okay, so the first thing we want to do is get moles of nitrogen. Moles of nitrogen is equal to 25.0 grams of nitrogen times what? Well, I have 1 mole per, let's go back to my periodic table. Where's nitrogen? 14.01, 14.01. So I have 2 times 14.01 grams per mole. Why is 2? Because I have N2, right? And that'll give me my moles. And what are my moles? Okay, 25 divided by 2 divided by 14.01. And it looks like I get 0.8922. I want to carry an extra non-sig fig here. Mole of N2. Now I want to calculate my moles of ammonia. So moles of ammonia. And this is what? From N2, right? So I'm going to take my 0.8922 moles of N2 times my mole ratio, right? 2 moles of ammonia per 1 mole of nitrogen. So multiply that by 2 times 2, and it looks like you get 1.784 moles of NH3, which would be produced by reacting all of my nitrogen. Now we do the same thing with my hydrogen, right? So how many grams of hydrogen? 20 grams of hydrogen. So I want moles of hydrogen, which is equal to 20 grams of hydrogen times what? 1 mole per 2 times 1.008 grams. So what do we get here? 20.0 divided by 2 divided by 1.008, and I get 9.920 moles of H2, right? And now we want to figure out moles of ammonia from my H2. So if all of my hydrogen were to react, how many moles of ammonia would I get? Well, it would be 9.920 moles of H2 times my mole ratio. What's my mole ratio? 2 moles of ammonia per what? 3 moles of H2, Yahoo, times 2 divided by 3, and I get 6.613 moles of ammonia, right? Now, according to our rules, we want to compare these amounts. Okay, I have 1.784 moles of ammonia. I have 6.613 moles of ammonia. Which one is less? This is the lesser amount. The lesser amount comes from my limiting reagent. So what is my limiting reagent? There's my limiting reagent. If that's my limiting reagent, that means this is my excess reagent. Now, we want to figure out how much of my hydrogen is left. So what did I say we do? We want to calculate the amount of excess reagent used. So excess reagent used. How do I get that? I'm going to take my amount of limiting reagent. Where's my amount of limiting reagent? Right here. 0.8922 moles of N2. And then how am I going to get my H2 used, right? My limiting reagent was H2. How do I figure out H2 used? Well, mole ratio. Mole ratio of H2 to what? N2. So let's look up here at our equation. I have 3 moles of hydrogen per 1 mole of nitrogen. So 3 moles per 1 mole. Okay, so I'll take my 0.8922 times 3 divided by 1, and I get 2.676 moles of H2 used. Good. Now, how do I get moles of H2 remaining? How do I get moles of H2 remaining? Well, I'm going to take the moles of H2 I start with. How many moles of H2 did I start with? Here's my moles of H2 right here, my 9.920. 9.920 moles of H2 minus how much was used up? 2.676. And what do we mean used up? That's how much was reacted with my, where is it? With my, there it is right there, with my 0.8922 moles of nitrogen. For my 0.8922 for my 0.8922 moles of nitrogen to react, it requires 2.676 moles of my hydrogen. So I subtract that from my 9.920, and what do I get? Ooh, let's see. 9.920, and it looks like it is 7.243. Well, that's about right. I'm going to round that because we're going to round this and this. And so my answer would be, that doesn't look right, does it? 7.2. I guess when it's rounded, yes. When we round these things, we get 7.24. No, you know what? Yes, that's correct. Moles of H2 left over. There we go. Just to say 9.920 minus 2.676, and I get, yeah, that's what that should have been. All right, when we round it, we get 7.24 moles left over. Not so hard. You just have to keep your head and do it, right? Okay, you guys try this one. Bring me back when you're ready. Well, we've already done this calculation before, at least part of it. So let's go back and we'll steal some information. How many moles of NO2 does this equal? Well, if we go back to our previous, where's my moles of NO2? I have 26.602. So this is 26.602 moles of NO2. And how many moles of water did I have from this 1224? Let's go back here. How many moles of water? Moles of water. Where's my moles of water? 67.939. So I have 67.939 moles of water. Okay, and then what would we do? We'd say, hey, I need to figure out moles of moles of nitric acid, right? Which is going to be 26.602 moles of NO2 times my mole ratio, 2 moles of HNO3 per what? 3 moles of NO2. And so what do I get? Let's take my 26.602 times 2 divided by 3, and I think I get 17.734 moles of HNO3. And if I figure out the moles of HNO3 that would be produced from my water, 67.939 times my mole ratio, 2 moles of HNO3 per 1 mole of water. And what do I get? 67.9, oops, got it wrong. 67.939 times 2 divided by 1. Did I do that right? 67, looks like it. I get 135.87 moles of HNO3. Let's go back and check. Is that right? 135.8 and 67, and 17. Okay, looks right to me. Just checking my old work. Now what do? We compare these two, right? We compare this to this. Which one is the smaller amount? This is the smaller amount, meaning it came from where? It came from my nitrogen dioxide. Nitrogen dioxide, yes, which means it's the limiting reagent, which means my water is the excess reagent. And now we want to figure out how much water reacted. So moles of H2 used is going to be equal to what? We take my 26.602 moles of NO2 times the mole ratio between those two pups, right? 1 mole to 3 moles. 1 mole of H2O per 3 moles of NO2. Yahoo! Good. And what do I get? So I take 26.602 times 1 divided by 3, and I get 8.8673 moles of H2O, which are what? Used. How much is left over? leftover H2O. Well, it's going to be how much we started with. How much did we start with? We started with 67.939 minus how much which was used? 8.8673. And what do we get? Zoink! 67.939 minus 8.8673, and I get 59.0717, but I could only be significant to the thousandths, so it's right here. So it's 59.072 moles of H2O left over. Good. Is that what we asked for, or did they ask for grams? How many grams? Leaks. So I have moles here, so what do I have to do? Need to multiply this by times the molar mass of water, 2 times 1.008 plus 16.00, zoink. Okay, let's see if we can do this. Store 2 times 1.008 plus 16, yoink, times recall 1, woohoo! How about 1064, 4 sig figs, grams of H2O left over. That's how we do it. All right, folks. I think I'm going to leave you here, and next time we will finish off the chapter. Ciao.